Welcome to our comprehensive walkthrough of LeetCode problem number 200, Number of Islands. In this session, you will learn how to approach and solve this foundational graph traversal problem, understand various strategies and their trade-offs, and work through several detailed examples. We will cover both Python and Java implementations, analyze time and space complexity, discuss common pitfalls, and share practical interview tips. This lesson is targeted at interview preparation and deepening your understanding of core graph algorithms. Let's dive into the complete problem statement for LeetCode problem number 200, Number of Islands. You are given a two-dimensional MXN grid of characters, where each element is either 1 for land or 0 for water. The goal is to count the number of distinct islands in the grid. An island is a group of adjacent lands connected horizontally or vertically. Diagonal connections do not count. The grid is surrounded by water on all sides. Now, let's examine the provided examples. In example 1, the grid has a block of ones connected together in the top left, with zeros on the right and bottom. Since all the ones are connected horizontally or vertically, they form a single island, so the output is 1. In example 2, there are two separate blocks of ones in the top left and two more disconnected areas in the right and lower part of the grid. After checking connectivity, we find 3 distinct islands. Each island is separated from the others by at least 1 zero. In both examples, adjacency is strictly horizontal or vertical, not diagonal. Continuing with the problem statement, let's look at the constraints and edge cases. The grid can have up to 300 rows and 300 columns, making performance vital. Each cell in the grid contains either a 0, water, or 1, land. Edge cases you should consider include grids with only water, which must return 0 as there are no islands. If the grid has only land, or all cells are 1, there is only 1 island. Single-cell islands are valid and need to be counted. Islands can touch the border without any issue. You should also handle single-row or single-column grids correctly, as well as large grids with multiple disconnected regions of land. Handling all these cases will ensure a robust solution. Let's analyze different solution strategies for LeetCode problem number 200. The most direct approaches are depth-first search, or DFS, and breadth-first search, or BFS. With DFS, we check all neighbors recursively or via a stack, marking visited cells to avoid repeated counting. BFS similarly explores all neighbors, but in level order using a queue. Another advanced technique is union find, or disjoint set union, where we treat each cell as a node and unite adjacent land cells into the same set. This lets us count unique parents to determine the total islands. All three are valid, but DFS and BFS are preferred for their simplicity and minimal extra work, especially when mutating the grid directly to mark visited cells. We'll choose DFS for its clarity and straightforward implementation, but keep in mind that BFS, and even union find, can work just as well depending on the interviewer's preference. Let's break down our solution for LeetCode problem number 200 step by step. First, we initialize an island counter to 0. We then loop over each cell in the grid. Whenever we find a 1, that means we've found land that's part of a new, unvisited island. At this point, we increment our island counter and initiate a DFS starting from this cell. The DFS explores and marks all connected ones, changing them to 0 so they aren't counted again. We repeat this process until all cells in the grid have been examined. At the end, our counter reflects the total number of distinct islands. The key benefit of marking in place is memory efficiency. We don't need a separate visited matrix, making our code cleaner and faster. In terms of implementation, we can choose either recursive DFS or an iterative approach with an explicit stack. Large grids may exceed Python's recursion depth, so be cautious. Always check boundaries before visiting neighbors to avoid out-of-range errors. If you choose BFS, you'll use a queue instead to manage your expansion, which can help with recursion limits. Union find, while more complex, is suitable for situations where mutating the grid is not allowed or if you need to answer dynamic connectivity queries. If the problem restricts grid modification, use a separate visited set to keep track of processed cells. These details ensure your algorithm is robust and adaptable to variations of the problem. Let's walk through the Python implementation for LeetCode problem number 200, number of islands. We define the number islands method, accepting a grid of strings. If the grid is empty, we return 0. We then determine the dimensions of the grid and initialize our island count to 0. Next, we define an inner recursive DFS function. For any land cell, we mark it as visited by setting it to 0, and then recursively call DFS on each of its 4 neighbors. The main loop iterates over every grid cell. When a 1 is found, we increment our count and launch DFS to mark the entire island. After the process is finished, we return the island count. Here is the Java solution for LeetCode problem number 200, number of islands. The logic is the same as our Python approach, but note the strong typing and class structure required in Java. The number islands method iterates over the grid, counting islands and invoking a private depth-first search helper for each new land cell. Cells are marked as visited by setting them to 0. The method signatures and variable declarations are explicit due to Java static typing. Both implementations use DFS and mutate the grid to avoid extra space. Let's walk through a step-by-step example for LeetCode problem number 200. In our sample grid, the algorithm starts at cell 0, 0, finds a 1, launches DFS, and marks the connected block of land, counting 1 island. It skips over water and lands already visited. When it encounters a new one at 2, 2, it detects a new disconnected island and marks it. Finally, at 3, 3, it finds another disconnected region, marks the 2 adjacent lands, and increases the count again. At the end, the output is 3, matching our expectations from the examples. Now let's look at special edge cases. For a grid with a single 0, there is nothing to count, so the answer is 0. For a grid with a single 1, it's a single island, so we return 1. We also handle large connected blocks, such as a 5x5 all-land grid, where despite its size there is only 1 island. Our algorithm correctly counts islands in all scenarios, including the smallest and largest possible grids. Let's analyze the performance of our solution to LeetCode problem number 200. Since every cell in the grid is visited at most once, the time complexity is order m times n, where m is the number of rows and n the number of columns. For space, if you recursively call DFS, the stack can grow as large as the number of land cells in the worst case. That's again order m times n. We don't need a separate visited matrix if we mutate the grid. If you use an explicit stack or queue in BFS, the space complexity is similar. This is optimal for this class of problem. Comparing approaches, both DFS and BFS deliver optimal time and space efficiency for LeetCode problem number 200. The union find method performs similarly in terms of big O analysis, but adds implementation overhead and complexity. For most cases, DFS or BFS provides the best blend of speed, simplicity, and reliability. LeetCode problem number 200 is foundational for mastering graph traversal. You are likely to see related problems such as finding the maximum area of islands, counting closed islands, or determining the perimeter of islands. Always pay attention to grid boundaries and be prepared for variations where you can't modify the input. Make sure to practice with both iterative and recursive approaches, and explain your choices clearly during interviews. This will demonstrate your understanding of algorithms and efficient problem solving. That's the end of this tutorial. I hope you found this explanation helpful for understanding the solution to this LeetCode problem. If you enjoyed this content, please consider subscribing to the channel for more coding tutorials and solutions. Feel free to leave a like if this video helped you, and don't hesitate to comment with any questions you might have. Thanks for watching, and happy coding!